Hello, in this video I am going to discuss about projectile motion. First of all, what is projectile? If any object is thrown into the air and followed a curved path, and then such motion are known as projectile motion. Projectile motions are basically occurs near the surface of the earth. There are two assumptions. The first one is the free fall acceleration g, which is constant and is acting directly downward over the range of the projectile. And the second assumption is that we are not considering the air resistance. So here we are neglecting the air resistance. So air resistance is neglected. Now, first of all, I am going to take a frame of reference. Here, this is a frame of reference for the motion which I am going to explain here, the projectile motion. So this is our x and y frame of reference. This is our y-axis and this is our x-axis. And here, this is the origin from where the particle is projected with some velocity vi. So it followed the path like this. For let's say this point is A. From this point, a projectile is projected with velocity some vi, and let's say at this point, and the component of velocity on the horizontal direction is, let's say, vxi, and on y direction it is vyi. Let's say at some point B, the velocity vi is in this way, and in x direction that is vxi, and y direction it is vyi. Now at the topmost point at point C, the velocity is only in the horizontal direction, because in the vertical component of the velocity is 0 at the topmost point. So we have only vxi here. Now at some point B, the vertical velocity is in the downward direction, that is vyi is like this, and this is our in the tangential direction, this is our vi, and this is our horizontal velocity, that is vxi. Now at point E, if we talk about this point, this is our downward direction velocity, that is vyi here, and this is our horizontal direction velocity, that is vxi, and this is our vi velocity. So in this way, and one thing is that and the projectile is projected from this point. This is the origin where x coordinate and y coordinate is 0. At time t is equals to 0, the xi coordinate is 0 and the xi coordinate is 0 and yi coordinate is also 0 at time t is equals to 0, and this projectile is projected at any angle theta I. At angle theta I with the horizontal, the projectile is projected with velocity vi, and at the point from where the projectile is projected at the initial time t is equals to 0, xi and yi are 0. Now I am going to discuss about its motion, how it behaves, how we can say just that these motions followed a parabolic path. So first of all, I am using the sine and cosine rule here. Use sine and cosine rule. So we have cos theta I. For here, if we apply it, so cos theta I is what? Cos theta I is, I can just say that here vxi by vi, and sine theta I is, what I can say is vyi by vi. So here we can say vxi is what? Vi cos theta I, and vyi is what? Vi sine theta I. Okay. Now I am going to discuss its motion in horizontal direction. So first of all, after time t, after time t, position in horizontal direction. So horizontal position. Yeah, horizontal position, that is, if we talk about, initially the particle in horizontal direction is at point A, where xi is 0, and if we talk about the acceleration is x direction, that is also 0. So as I am explaining here, our acceleration is just the downward direction, and if we take this direction as positive direction, the vertically up y direction is positive, then the acceleration is acting just vertically downward. So this acceleration in y direction, if I say ay is minus c, and acceleration in x direction is 0, because there is no acceleration acting in the horizontal direction. So x direction acceleration is 0, and y direction acceleration is ay is equals to minus g. So here, if we talk about x final is what? Vxi into t. After time t, I am talking about the position. So Vxi, the velocity in x direction, plus half ax t square. Ax is 0, so we have Vxi t to t. And Vxi is what? From here we can say Vxi is Vi cos theta I. So Vi cos theta I into t. So this is our x direction position. This is our equation number 1. From here we can derive t. So t is what? T is just our x final upon Vi cos theta I. Okay. Now in vertical direction, vertical position, I can say, after time t, vertical position after time t is as initial vertical position yi is 0, and acceleration in y direction is minus g. So we can say that y final is what? Y final is v yi into t minus half z t square. Okay, and here if I can just put here the value of this Vyi, so that is Vi sine theta I into t minus half zt square. Okay, and now this is our equation number 2. If I put this value here, the value of t in this equation, and so what I can get is, this is, so Vi cancel out Vi, so I have left with what? I have left with only, so I can just put it here. Y in general I am writing here, so I can just write it as this. If in general y is equals to, because the equation which come here is valid for all the values of x and y, so I can just write it in general. So y is equals to what I can say is the tan theta, x time of tan theta, yeah, I'm taking it in general. So I here minus zx square by 2 time of vi, or v square, I can generally write it v square cos square theta. Okay, this is our equation number 3. Now here the value of theta for which this equation is valid is tending from pi by 2 and 0. In between 0 and pi by 2, the value of theta is tending, and for these values this equation is right. Now if I am just writing this equation as y is equals to ax minus bx square, and this equation is nothing but the equation of parabola passing through the origins.